As a data scientist, you'll often be working with tons of data. The form of this data can vary greatly, but pretty often you can boil it down to a tabular structure. Let's have a look at some examples. Suppose you're working in a chemical plant and have a ton of temperature measurements to analyze. This data can come in the following form. Every row is a measurement or an observation, and for each observation there are different variables. For each measurement there's of course a temperature, but also the date and the time of the measurement and location. Another example. You have collected information on the so-called BRICS countries: Brazil, Russia, India, China and South Africa. You can again build a table with this data, like this. Each row is an observation and represents a country. Each observation has the same variables: the country name, the capital, the area in millions of square kilometers, and the population in millions. To start working on this data in Python, you'll need some kind of rectangular data structure. That's easy, we already know one. The 2D NumPy array, right? Well, it's an option, but not necessarily the best one. Remember that NumPy arrays can only house elements with the same data type? Well, in the two examples we covered, there are different data types. In the BRICS example, the area and population are floats, while the country and capital are string. Their datasets will typically comprise different data types, so we need a tool that's better suited for the job. To easily and efficiently handle this data, there's the Pandas package. Pandas is a high-level data manipulation tool developed by Wes McKinney and is built on a NumPy package. Compared to NumPy, it's more high-level, making it very interesting for data scientists all over the world. In Pandas, we store the tabular data like the BRICS table here in a so-called data frame. Have a look at the Pandas data frame version of the BRICS data I showed you before. You see a similar structure. The rows represent the observations and the columns represent the variables. Also notice that each row has a unique row label: BR for Brazil, RU for Russia, and so on. The columns, or variables, also have labels: country, population, and so on. Notice that the values in the different columns have different types, a big difference with 2D NumPy arrays. This is all great news, but how can you create this data frame in the first place? Well, there are different ways. First of all, you can build it manually, starting from a dictionary. Using the distinctive curly brackets, we create key-value pairs. The keys are the column labels, and the values are the corresponding columns in list form. After importing the Pandas package as PD, you can then create a data frame from the dictionary using pd.dataframe. If you check out BRICS now, we're almost there. Pandas assigns some automatic row labels, 0 up to 4. To specify them manually, you can set the index attribute of BRICS to a list with the correct labels. The resulting BRICS data frame is the same one as you saw before. Using a dictionary approach is fine, but what if you're working with tons of data, which is typically the case as a data scientist? Well, you won't build a data frame manually. Instead, you import the data from an external file that contains all this data. Suppose the BRICS data that I showed you before comes in the form of a CSV file called brics.csv. CSV is short for comma separated values, by the way. Let's try to import this data into Python using Pandas read_csv function. You pass the path to the CSV file as an argument. If you now print BRICS, there's still something wrong. The row labels are seen as a column in their own right. To solve this, we'll have to tell the read_csv function that the first column contains the row indexes. You do this by setting the index call argument like this. This time, BRICS contains the data frame we started with in this video. It nicely contains the row and column labels. The read_csv function features many more arguments that allow you to customize your data import. Make sure to check out this documentation. Now head over to the exercises to experiment with building data frames yourself.